Imagine something so small that it is 25,000 times smaller than the width of one strand of hair. Obviously, this thing is invisible to the naked eye, but it is also invisible to an optical microscope. Now stop imagining and realize that this is not a science fiction story. This is nanotechnology. Nanotechnology is the present and future of science. It is being used to better medicine, getting clean energy, and improvements of electronics. So, what is nanotechnology? Nanotechnology is the construction of structures at the molecular level. Essentially, it is reassembling how a compound is arranged and forming new allotropes. An allotrope is just a different form in which an element can exist. And a common example is how diamonds and graphite are both made of carbon, but obviously are two very different structures. One is a flaky, um, it's a flaky like structure used in pencils, and the other is the strongest material on Earth. Nanotechnology aims to find the best allotropes and elements and to find their best form. Due to the molecular scale, though, that they must work with to rearrange atoms, they have to use their own measuring scale, which they call nanometers. A nanometer, according to the Center for Responsible Nanotechnology, is 1 billionth of a meter and is about 3 to 4 atoms wide. Nanotechnology uses mechanochemistry to insert atoms into precise locations to make chemical compounds. These compounds can make a structure stronger, lighter, and more flexible, or all three. So, some of the benefits that nanotechnology offers, according to the National Nanotechnology Initiative, or the NNI, which was founded by Bill Clinton when he was president to research nanotechnology. Nanotech can be used to benefit medicine, energy harvesting, and electronics. In the medical field, two health problems nanotechnology researchers have been researching is treatment for cancer and paralyzation. Research is being worked on to try and make a medicine using nanotechnology that could be used to deliver a medication directly to cancerous cells. This would make chemotherapy much less detrimental to healthy cells, as it would only target the cancerous cells and not all of them. For paralyzation, researchers have been working on growing neurons on conductive graphene nanoribbons. If they're able to grow neurons, they could use them to help patients who are paralyzed regain some of the function in their limbs or all of the function over time. Some of the benefits that nanotechnology is being used for energy is solar panels are being shrunk to a thin sheet that can be printed in large rolls, allowing them to be made inexpensively and faster than their larger counterparts. They're also working on paintable solar panels, but that's pretty far off right now. Carbon nanotubes, which are an allotrope of carbon in cylindrical form, are being used to make windmill blades stronger, lighter weight, and longer, allowing them to create more energy from wind. In the electronics field, quantum dots, which are semiconductor particles used to emit light of specific frequencies, or just colors, are beginning to be used in TVs and electronic screens to give off more vivid and crisp colors, and this can only be used using nanotechnology. Researchers at the NNI are also have been using nanoparticle copper suspension to fuse electronics together due to it being safer, less expensive, and more reliable than a lead-based solder. However, nanotechnology is not just all benefits, and there is some pretty serious drawbacks to it. One of these is nanopollutants. Nanopollution is basically any waste matter or byproduct made in the manufacturing or use of nanotechnology. Many nanoproducts are not biodegradable, which obviously they can't degrade into the earth, and that's very bad. Due to the minuscule size of nanotechnology, some of the pollution can also enter living cells. This can cause a number of horrible diseases if the body cannot eliminate these small particles. It is also important to realize, though, that people are already exposed to a lot of nanopollution from car exhaust and construction sites, and that nanopollution is not a new thing, but with the increased use of nanotechnology in the future, it could become very serious. According to the Future for All, some of the diseases that have been associated with nanoparticle exposure are Parkinson's disease, Alzheimer's disease, heart disease, colon cancer, and autoimmune diseases, just to name a few. The second drawback that nanotechnology has and could possibly be the most serious is the use of nanoweapons. So, as usual, as beneficial technology advancements happen, weapons also usually tend to advance as well. This was shown with nuclear research turning into the formation of nuclear bombs. There are some serious risks if nanoweapons are put into the wrong hands, because with the precision that these weapons could be made with, the effects could be detrimental due to their small size and them being nearly undetectable. The technology is not available yet, but in the near future, it is very likely that a chemical war could happen where robots as small as mosquitoes could be used to carry poisons and could inject a target with a poison. And if in the hands of a terrorist, this futuristic technology could become very scary and lead to a very uncertain future. So, in conclusion, nanotechnology is the present and future of science. With its benefits in many fields, including medicine, energy, and electronics, it has equal drawbacks, in weaponizing this technology and pollution. It will need to be kept in check as the field of science continues to advance. It is up to us, our politicians, and the nations on Earth to determine if we will use this technology to better our lives or to destroy them.